Alrighty. If the sound sounds a little bit different, it's because my wireless mics ran out of power, so I'm switching back to the original mic that came with the camera. I don't think it's that big of a difference or that big of a problem, but um, yeah, I'm gonna have to record. I'm not re-recording the videos that I think I lost the sound for, so I'll just talk with you all about that in the class. It's basically just more of this. It's basically just doing two-step sequences. We did some sequences with two steps before. The versions that you got bonus versions of the sequences on Canvas, but we're basically just going to do more transformation sequences here, and it's going to be the review for assessment 3.2. So let's get started. We've got DEFG with vertices -2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. There we go. 2, 3, 1, 2, 1, 2, 3. 0, 1. That's easy. And then -4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Alrighty. So there we go. I'll get you on the center of the screen here. Alrighty. So that is, hang on one second. Got to recenter something. There we go. So that is that is our pre-image. Whatever we do to it now, it's going to be the first transformation. So the first transformation, we're going to use the vector notation for 6, -8. So what that means is +6 means we're going to move it to the right 6 spaces. Then -8 means we're going to move it down 8 spaces. So we're going to move it in the negative y direction 8 spaces. When I say it, what do I mean? I mean this whole drawing, but specifically, I mean every single point on this drawing for the transformation. So I'm just going to go point for point. I'm going to add 6 to the x, then I'm going to subtract 8 from the y. So 6 -2 is 4. 7 -8 is -1. I think, yeah, that's all in frame. All right. 6 plus 2 is 8. 3 -8 is -5. 0 plus 6 is 6. 1 -8 is -7. And I've got 6 plus -4 is 2. And then 5 -8 is -3. I mentioned this in one of the other videos, and I want to be 100% clear on this. Whenever you're dealing with a translation, you shouldn't ever have to worry about with negative signs or positive signs or any of the integers. You should never have to be concerned about whether or not you're adding a negative or subtracting a positive. Here's the way you know you're doing it right. If you have a negative number and your math doesn't make the y coordinate more negative than where it started from, you've made a mistake. If you have a positive number, like in this case with 6, and you do your math and every coordinate is not more positive than what it started out with, then you have also made a mathematical mistake. Purpose with translation is just to move it along the grid of this graph. And so you're really just, again, moving it 6 spaces to the right, 8 spaces down. So if whatever you do, when your math is done, this picture is not farther down or to the right, then you've made a mistake. You've messed up. So let's see what this first transformation looks like. So I've got 1, 2, 3, 4, -1. Then I've got 8, 1, 2, 3, 4, 5. And I get 6, -7. 2, 3, 4, 5, 6. Yep, 6, -7. And then 2, -3. 1, 2, 3. All right. Yeah, that was a pretty good translation. I'm pretty content with that. Let's see what the next one is. Reflection in the y-axis. All right. So what we're going to do is wait. That's y equals x. So when we're reflecting in the y-axis, it means that all of the y coordinates are going to stay the same. So reflection in the y-axis, x and y, all the y coordinates are going to stay the same. So when we flip this image over, and it's going to be across this axis here, there we go, it's going to be across this axis here, all the y coordinates are going to be the same. This is going to be -1 over here, this is going to be -3 over here. So because all the y coordinates are going to be the same, I can already fill this in. 1, -5, -7, -3. All right, save myself some time. Not that reflection transformations are going to be that big of a problem or that big of a deal. Basically, whatever the x-coordinate is, you're going to take -x, and then you're going to leave y exactly the way that it is. So what this means is 4 becomes -4, 8 becomes -8, 6 becomes -6, and then 2 becomes -2. So now that we've figured that out, let's see what the transformation looks like. So I've got -4, 1, let's see, -4, -1, 1, 2, 3, 4, -1, all right. I've got -8, -5, 1, 2, 3, 4, 5. I've got -6, -7, 6, -7. And then I've got -2, -3, 1, 2, 1, 2, 3. And so this is A prime, this is A double prime. So yeah, there we go. We translated it over here, and then we reflected about the y-axis, so here we are. Sequence is complete, and we've got all of the different points, and as a bonus, I even notated which was the pre-image, the first image, and then the second image. So here we go. Let's move on to the next one. If you keep in mind, this is a 2-page document. So yeah, we've got more. We've got more to do. So we've got triangle L, M, and N. Alrighty, I always prefer working with triangles because there's only 3 points. It goes 6, 6, 8, 8, and 8, 3. So 1, 2, 3, 4, 5, 6, 6, 6, 6, 8, 8, and then 8, 3. So we got a little bit of a triangle here. So reflection in the line x equals 5. So I got 1, 2, 3, 4, 5. All right. Reflection in the line x equals 5. So I've got 2 options here. The first one is I can just look at it and say, all right, well, this is 1 point away. Well, this is 1, 2, 3 points away. And this is 1, 2, 3 points away also. Isn't that good enough? The answer is yes. The answer is yes, that is good enough. All you need to do is then figure out what the points are. Let's see, 6, 6, so this one would be 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So 4, -6. Let's see, that one was 8, 3, so that's going to be 1, 2, 1, 2, 3. So 2, -3. This would be a lot easier if I'd labeled these. And so we got 2, -8. And there we go. That would be where we start out. So 2, -8, 2, -3, and then 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There we go. That's the first translation. The other option is to go the first route, where if you have x and y, where x is rotated about a, just generally a, then what you do is you do 2 times a minus x is your new x coordinate, and then the y is unchanged. So again, we see the first reflection, and then the y's are largely unchanged when it comes to the x coordinate. Anyway, you know what I just realized? I did negative numbers rather than positive numbers. So yeah, even though the reflection is correct, I did not put the numbers where they should have been. This should all be up here. So this triangle should be all the way up here. This reflection should be all the way here. You know what? It's been a long enough shoot. I will just go for 80% credit and just move on from here. So 270 degrees counterclockwise rotation about the origin. So 270 degrees counterclockwise is the same as 90 degrees clockwise. And 90 degrees clockwise, that transformation is xy, 90 degrees clockwise. For those chemistry folks, that is kind of what I kind of do for shorthand. Let's see, yeah, y negative x. There we go. I had to check my notes there for a second. So whatever x is, it becomes y. Hang on, there we go. Whatever x is, it becomes y, and whatever y is, it becomes negative x. So whatever x is, it becomes y, so negative 6. Whatever y is, it becomes negative x, negative 4. Whatever x is, it becomes y, so negative 8. Then y becomes negative x, 2. X becomes y, so negative 3. Then y becomes negative x, negative 2. So yeah, while we're here, we may as well finish the rotation. 1, 2, 3, 4, 5, 6. 2, 3, 4. There's that one. 8, and then negative 2. And then negative 3, and 2, 3, negative 2. There we go. Yeah, that looks about right. Yeah, not bad for putting it in the completely wrong quadrant. Yeah, you know what? If this is the difference between secure and secure plus, I will eat that. I will own that. That's on me. But otherwise, the transformations work perfectly. You just kind of got to look outside the, just because you're given a set of coordinates doesn't mean that you have to stick with them, Anyway, quadrilateral ABCD with vertices 0, 6. I got 0, 1, 2, 3, 4, 5, 6. 0, positive 6. Negative 3, negative 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Saw that moment of hesitancy. Negative 9, negative 6. So that's negative 9. 1, 2, 3, 4, 5, 6. And just be clear, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that is awfully embarrassing. I'm used to larger graphs being negative 9 like that. So once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, we're good now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then minus 3, 1, 2, 3. Alrighty. We have a quadrilateral that is that really what it, well, all right. Got a goofy looking quadrilateral, but all right, we'll work with it. Dilation with a scale factor of 1/3 centered at the origin. All right, so what that means is for every x and y, k is going to equal 1/3. And so that means that for every x, it's going to be 1/3 times x. And then for every y, it's going to be 1/3 times y. All right, so let's get started. 1/3 times 0 is 0. 1/3 times 6 is 2. 1/3 times negative 3 is negative 1. 1/3 times negative 6 is negative 2. 1/3 times negative 9 is negative 3. 1/3 times negative 6 is negative 2. 1/3 times negative 12 is negative 4. And then 1/3 times negative 3 is negative 1. All right, let's see what that looks like first. Let's see what that looks like with the dilation about the origin. So equals 0, 2, negative 1, negative 2, negative 3, 1, 2, 3, negative 2, then negative 4, negative 1, 1, 2, 3, 4, negative 1. All right. Still a pretty goofy looking quadrilateral, but we've made it smaller, so I guess mission accomplished as far as the dilation is concerned. Now we are going to do a translation along the vector -5, -1. So going back to Quagsire notation, x, this is the same as x minus 5 and y minus 1. So every x coordinate, we're going to subtract 5, which means we're going to move it to the left. And every y coordinate, we're going to take away 1, so we're going to move it down. So by the time we're done, our x's should all be more negative, and our y's should be slightly more negative because it's just a 1. Well, let's get started. So I've got minus 5 minus 0 is minus 5. Negative 1 minus 5 is minus 6. Negative 3 minus 5 is minus 8. And then negative 4 minus 5 is minus 9. All right. 2 minus 1 is 1. Negative 2 minus 1 is minus 3. Negative 2 minus 1, also minus 3. Negative 1 minus 1, minus 2. All right, so it checks out with the smell test because every one of these points is more negative, both in the x and the y. So whatever my math is, whatever these numbers are, I know I did the math correctly. At least I hope I did. It's been a long shoot. So 1, 2, 3, 4, 5, and then 1. Then 1, 2, 3, 4, 5, 6, and then negative 3, 1, 2, 3. Negative 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3, 1, 2, 3. Then negative 9, negative 2, 1, 2, 3, 4, 5, 6, 7, 9, negative 2. All right, and we have moved our goofy looking quadrilateral from over here down to here, which is exactly what the translation was supposed to be doing. So we can consider this a wild success, not like this one. All right, now we're moving on to page 2 because we have been told. This is what we've been told. So let's move on to page 2. Starting to get a little punchy. All right, triangle XYZ. Oh, thank goodness. So we've got triangle XYZ with negative 6, 4. So 1, 2, 3, 4, 5, 6. And then positive 1, 2, 3, 4. Y is 0, 6. So 1, 2, 3, 4, 5, 6. And then Z is negative 4, 2. 1, 2, 3, 4. And then positive 2. All right, so we've got our triangle. Now, what is the first transformation we got to do? We've got to rotate it 180 degrees counterclockwise. Well, you know what? I'm going to rotate it 180 degrees clockwise because I'm a rebel. I'm really not. But the transformation is exactly the same. Whatever x is, it becomes negative x. Whatever y is, it becomes negative y. That's literally the transformation. So let's get started with the transformation. Negative 6, 4 becomes 6, negative 4. 0, 6 becomes 0, negative 6. Negative 4, 2 becomes 4, negative 2. So let's see what that looks like. So I got 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. I think that's barely on the screen. There we go. 6 and 4. And I got 0, negative 6, 1, 2, 3, 4, 5, 6. I got 4, negative 2, 1, 2, 3, 4, negative 2. All right, first transformation is in the books. Let's move on to our second one. Dilation with scale factor of 3/2 centered at the origin. So what that means is for every x and y that we have k of 3/2. So that means for every x we have, it's 3/2 times x. And for every y we have, it's 3/2 times y. So whatever x we start with, we multiply it by 3/2, and that gives us what we end up with. So 6 times 3/2, and this is kind of how long the shoot has been going. That I'm just gonna do this. 6 times 1.5 is, there we go. We don't need to see the graph quite yet, but yeah, this is how long the shoot's been going. So 6 times 1.5 is 9. Negative 4 times 1.5, negative 6, 0. Then that's going to be negative 9 because negative 6 times 1.5. Yeah, I figured. 4 times 1.5 equals 6. 2 times 1.5 equals negative 3. Yeah, this is how tired I am right now that I would rather just go through with the calculator. I mean, I'm messing up the drawings anyway, so I may as well do this. All right, so we're dilating with a scale factor of 3/2. That means that whatever we have, it's going to get bigger. Not by much, but it is going to get bigger. So let's take a look. We've got 9, negative 6, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6. All right, there's the first one. Then 0, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All righty. And then 6, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. There's that. So our triangle has gotten, it's gotten a little bit bigger. It's gotten appreciably bigger, enough that we can say we have a scale factor of 3/2 anyway. So yeah, that is the second one. That is another two-step sequence that we've got in the books. Way to go, team. All right, next one is parallelogram. 4 points. Work with what you got, All right, negative 3, negative 4. 1, 2, 3. 1, 2, 3, 4. 0, negative 3. 1, 2, 3. 1, negative 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. And then negative 4, negative 9, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives us, there it is. Yeah, there we are. That'll work. So we've got translation along the vector 7, 0. Well, that's actually pretty handy because the 0 means that I am not changing the y coordinates at all. I'm not changing them, I'm not altering them, I'm not doing anything with them. So that means that for the first transformation, negative 4, negative 3, negative 8, and negative 9. It also means that I don't have to do a great deal of math with all the other ones, but I'm going to do it anyway. So 7 minus 3 is 4. 7 plus 0 is 7. That'll be easy. Negative 1 plus 7 is 6. And then negative 4 plus 7 is 3. So basically, all I'm doing is for every point, I'm moving it to the right 7 spaces. So I calculated this out because I'm probably going to need it for the next transformation. But really, if you just have this as your final step, or this is your only transformation, what you can do is just go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. And there you go. Transformation complete. We've translated over exactly 7 spaces to the right, which is what this vector represents. And if you remember, we got the Quagsire notation, x plus 7, y plus 0. These mean the exact same thing. This is just a little bit more explicit about what to do with the x and y. All right, we've got one more transformation, 90 degrees counterclockwise. So, write this down here, check my notes. 90 degrees counterclockwise. Let's return this. X. There we go. So that means that every x becomes negative whatever y was, and then y becomes x. So that being the case, I'm just going to work through the y's first because it's just copying and pasting things directly. So y equals x, so that becomes 4, 7, 6, 3. All right. And then x becomes y, but negative. So whatever y was, flip the sign, and that's what you've got. So that gives me, so x becomes negative y. Yep. All right, x becomes negative y. So 4, 3, 8, 9. I'm having a hard time seeing because there's glare from the little overhead camera here, so it's kind of hard to see with the pencil. All right, so let's see what that actually looks like. I've got 1, 2, 3, 4. 1, 2, 3, 4. All righty. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6. And then 9 and 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. There we go. So we started with this one, translated over here. Then we did a counterclockwise rotation. That's what we ended up with. So yeah, that's transformations in sequence. We still have one more, don't worry. But that's pretty much all we're doing is we're doing one transformation at a time with the different variables that we're creating. So I've got triangle CDE with these vertices. So I've got -2, -2. I've got 1, -4, 1, 2, 3, 4. And then -3, -4. 1, 2, 3, 1, 2, 3, 4. And that is a triangle. We have got a triangle. All right, good night, everyone. No, I'm just kidding. So dilation with scale factor of 2. What that means is for every x and y we have k equal to 2. And so what that means is for every x that we have, we're going to multiply 2 times x. And then for every y, we're going to do 2 times y. That's also going to equal, for the more general form, whatever the scale factor is, you're multiplying all of the x's by that and all of the y's by that. So yeah, let's get started. We'll start with this one. We'll start with C. We'll just go across. So -2 times 2 is -4. It's the same number there. So 2 times 1 is 2. 2 times -4 is -8. Then 2 times -3 is -6. And then 2 times -4 is -8. All right, let's see what that looks like. So I got 1, 2, 3, 4, 1, 2, 3, 4. Got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then I've got 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. So it's the same general shape. It's just a little bit bigger, which is kind of what you want with the dilation anyway. All right, so let's see what the reflection in the line y equals x is. So this is the reflection of line y equals x. Now we haven't seen this transformation in a while, but the reflection of the line y equals x is, very simply put, you just switch the numbers around. That's all you're doing. Y becomes x, x becomes y. So for this one, it's right. Maybe not that big of a challenge. Yep. For this one, we got -8, 2. And this one -8, -6. All right. So let's see what we've got here. So I've got 1, 2, 3, 4. 1, 2, 3, 4. Well, all right, let's see what we got here. We're -4. -x. Oh, okay. Y equals -x. That does change things around. There we go. That's what it was. Y equals -x. I didn't see that negative there. -y, -x. Alrighty. All right. That makes a lot more sense. Because a reflection about a line, you shouldn't have overlapping dots. All right, so x transition for y equals -x. So I drew the line correctly. I just picked the incorrect conversion, which is fine. X becomes -y, which is 4, and y becomes -x, which is 4. All right, this makes a lot more sense. 8, -2, and then 8, 6. All right, this is going to look significantly different. So 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -2. And then 8, 6, 1, 2, 3, 4, 5, 6. There we go. That makes a lot more sense. So we're looking at these two things here. All right. Whew. There we go. That makes a lot more sense. So yeah, this is the second page. Yep, second page of the sequences of 2. If you really want to do more sequences, I've got some bonus sequences, and I've got some triple sequences for those who really do hate themselves. But yeah, if you can do this and all the other stuff, you should be set for assessment 2. So best of luck with that. I will see you in class.